Good morning, everyone. Today, we are presenting our innovation titled Energy Regenerative Tower Crane System using solar and gravity-based storage. Our team is led by Yufei. The following are our team members and our teacher advisor, Puan Aslina. Tower cranes are essential in Malaysia constructions, especially for high-rise building and major infrastructures in places like Kuala Lumpur and Selangor. These cranes use electric motor powered by the grid or temporary site system to handle lifting and hoisting.
There are four main weaknesses in conventional tower cranes. First, the braking system is inefficient. When a load is lowered, gravitational energy is converted into heat instead of being reused. Second, this process generates significant heat which accelerates material degradation. At the same time, mechanical friction brakes experience continuous wear, resulting in frequent maintenance and component replacements. Finally, most conventional systems lack regenerative capability, leading to high operational costs.
Moving on to our objectives. The main objectives are to reduce the electrical energy consumption of crane operations by minimizing dependence on grid power. The system recovers and reuses gravitational energy during load lowering through regenerative braking and incorporates solar energy into crane operations. Overall, this innovation lowers operation costs and reduces carbon emission.
Solar panel captures sunlight and generates electricity through photovoltaic cell, producing a direct current that will be converted into alternating current for industrial use. Because cranes normally operate in smoky, dusty industrial environments that reduces solar efficiency, our design uses half-cell monocrystalline solar panels. Half-cell technology is able to minimize power loss in partially shaded conditions, reducing a power loss by up to 50% compared to conventional solar panels, while also enhancing heat management, durability, and also performance in harsh conditions. On the other hand, monocrystalline solar panels are selected due to its high efficiency, about 22 to 27%. These solar panels will be installed on the counterjib due to strong structural support, sufficient space, and also direct access to electrical systems, ensuring reliable energy regeneration even in industrial conditions.
This is a simple model of gravity regenerative energy concept that is applicable in our tower crane. When electrical energy is supplied from an external source, the motor rotates and pulls the ropes upward, lifting load. During this stage, the motor operates in watering mode, consuming electrical energy to store energy in the form of gravitational potential energy. Once the load reaches a certain height, the lifting process stops. The system then allows the load to move downward in a controlled manner under the influence of gravity. As the load descends, its gravitational potential energy is converted into mechanical energy. This downward motion pulls the ropes and forces the motor shaft to rotate in the opposite direction. As a result, the motor changes its function and operates as a generator. Inside the generator, relative motion between magnetic field and conductor induces an electric current. According to Faraday's law, this current not only generates electricity, but it also plays a critical role in braking.
According to Land's law, the induced current creates a magnetic field that opposes the motion that produces it. As gravity tries to spin the motor faster, more current is generated, producing a stronger opposing electromagnetic torque. This torque acts as a contactless braking force, slowing the load smoothly without friction. Inside the hoist motor, alternating current is induced. The current flows to the variable frequency drive or VFD. The VFD rectifies this AC power into direct current and feed it into a common DC bus. At the same time, solar energy produced from the solar panel is delivered to the same DC bus. As regenerated energy and solar energy enter the bus, the energy management system in DC bus will decide how the energy is distributed. If energy storage is needed, the power flows through a DC-DC converter into a supercapacitor to absorb high power energy quickly before being transferred into the battery for long-term storage. If energy is required immediately, the DC bus supplies power to other crane motors or a control system for direct reuse. When regenerated and solar energy are insufficient, an external grid supply is used as a backup. The grid power is converted from AC to DC and connected to the same DC bus, ensuring continuous and reliable crane operation.
During daytime operation, sufficient solar energy is available and is utilized as the primary power source for the crane system. During nighttime operation, in the absence of sunlight, the crane system is primarily powered by stored battery energy. Energy recovered through gravity regeneration supplements the system during lowering operations, while the local electrical grid serves as a backup source when required. During high load conditions or emergencies, electrical energy can be supplied from the local grid.
Turning to the benefits of our innovative crane system, Our innovation enhances energy efficiency and recovery. In conventional crane, 10,000 kilojoules of energy generated during load lowering is wasted as heat through friction brakes. In contrast, our system converts gravitational potential energy into electrical energy, enabling 45 to 65% of energy recovered. Secondly, our system contributes to environmental sustainability. Traditional crane operation uses electricity generated from the burning of fossil fuels, resulting in the increase of carbon emission. Conversely, our system reduces overall energy consumption by up to 30%, further reducing environmental impact and supports SDG 7, affordable and clean energy. Lastly, our system reduces electricity consumption and operating costs. Traditional crane rely heavily on grid electricity, consuming 17 MWh per day. Our system integrates photovoltaic power and gravity-based energy recovery, which reduces dependence on grid electricity by 30 to 55%, resulting in significant cost saving.
In conclusion, we believe that the energy regenerative tower crane system provides a practical and sustainable solution to improve energy efficiency, lower operating costs and carbon emissions by recovering gravitational energy and integrating solar power. That is all from us, and thank you for your attention.